In this lesson, we're going to go over a quick review of the sine law. Again, it's something covered in grade 11, but just to remind ourselves of some of the ideas of how we can use this. Okay, Pythagoras and SOHCAHTOA are fantastic for right angle triangles. Unfortunately, most triangles aren't right angles. We need some other rules that we can use for things that aren't right angle. One of the best tools would be the sine law. And the way the sine law works is it examines the relationship between a side and its opposite angle. Okay, so the big key there is they have to be across from one another. So it doesn't matter which pair you use. You're usually going to have two of the three pairs, and we're going to match up angles and sides that go together. Be careful when we're using the sine law over here that it's the sine of your angle and the opposite side, the sine of an angle and the opposite side. Okay, big letters always stand for angles. Small letters always stand for the corresponding opposite side. There really are only two questions we can do the sine law. We'll take a look at them in just a second here. Okay. Our objective here is we want to set up a ratio that we can cross multiply and solve, kind of like we did when we did SOHCAHTOA. So let's take a look at the first triangle here. I want to solve the triangle. That is, I want to figure out all the parts and pieces that are missing. So before I start, I'm going to label some things. Across from big X would be a small x. Across from big Z would be a small z. I know triangles add up to 180 degrees, so I can actually figure out the third angle without doing any complicated math. 180 minus 50 minus 70 tells me the angle inside here is 60. And that would be angle Z, big Z. So if I want to start solving this triangle with the parts that are missing, which are small z and small x, I have to set up a ratio that I know. I know that the sine of 70 goes across from, or is across from 17. And I know the sine of 50, looking at x, would be across from the small x. So I can set this up to cross multiply and solve. It's a ratio, it's two fractions equal to each other. When we cross multiply this, we get x sine 70 equals 17 times the sine of 50. I want to get x by itself, so I need to divide out the sine 70 from this side. If I do that, I need to just divide out the sine 70 from this side. I can put that all in my calculator the way it looks. These two things will cancel each other out. And on the other side, if I do all that in my calculator, I end up with 13.86. All right, and that's it. I've solved side x. You guys can try to find side z if you want to. Pause it, give it a try, so you can figure it out. It's the same idea, though. So the sine, which one do I know for sure? I know the sine of 70 goes to 17. If I want to find z, I go to the sine of big Z, which you just figured out was 60 a second ago, goes to small z. Cross multiply. So z times the sine of 70 equals the 17 times the sine of, 60 there. I want to get z by itself, so I'm going to divide out the sine 70 from both sides. Sine 70, and for z, I'll end up with 15.67. There, we've solved for sides. Yeah, so that's one thing I can do with the sine law. The second thing I can do with the sine law is figure out some unknown angles. That's what example 2 is about here. Okay, so again, I've got a pair of things that I know. I know 32 can go with 43 for sure. So I can write down that ratio. It's not right angles. I'm using the sine law, right? If I want to find, I don't know, side or angle L over here would be across from 37. Well, I can write down the sine of L has to go with 37. Again, it's a ratio. I want to cross multiply and solve this. So if I cross multiply, it looks like 37 times the sine of 32 equals 43 times the sine of L. I want to get the L by itself. Now, I can't do that immediately, but I could divide out the 43. These two things will cancel each other out. I'll be left with a sine L. On the other side, I'm going to get this big long decimal. Now, I'm not going to remember the big long decimal. I just need the parts and pieces of it. And like SOHCAHTOA, when I want to get an angle, I need to take an inverse. Okay, so to get L, I'm going to take the inverse of that big long decimal that's on your calculator. 559 ... keeps on going. Okay, so I use your second function. If you type that in there, you should get 27.1 degrees. And I've got myself L. So if I were to add it to my diagram, and the reason I'm going to add to my diagram is, and we're going to point something out here in just a second. To get K, I can use that idea of, oh, triangles add up to 180, right? Once I know two angles, I can figure out the third one really quickly every single time. So K will equal, punch on my calculator, I get 120.9. Obviously this diagram is not to scale, and don't assume that they're always drawn to scale, okay? Now, what am I missing? Oh, I'm missing small k. I've got everything else but the other piece. How do I find a missing side? Well, let's set up the ratio that we absolutely positively know. The sine of 32 has to go with 43. That's one we know. Now, I could have used the other ones, right? I could use sine of 27.1 and 37. That's got decimals involved, so I just didn't bother with that one. Okay. The sine of 120.9, the one we just figured out, is going to go with k. And this is like the first example all over again. So we're going to cross multiply. So k times sine 32 equals 43 times the sine of 120.9. I'm going to get k by itself, so I can divide out the sine part. But if I divide one side, I got to do the same thing to the other side. And I get k by itself, which is great. I punch it on my calculator and end up with 69.6. Okay. That's all I can really do with the sine law. So I got finding angles, like the first part here, finding sides, like the second part. And if you flip it over, we'll try some little applications on the back.